Okay, so I'm recording now, and Noe, I'm going to go ahead and make you the presenter. So if you have a PowerPoint or whatever, go ahead and put that up. We're supposed to have, I think we have 12 people registered.
Okay.
Hi, Angelica.
Hi, everyone.
Hey.
Okay. Does everybody see my screen?
Yeah.
We can hear it, but you're kind of cutting in and out a little bit.
Did anybody else join besides Angelica?
No, so we have, right now we just have the 4 of us. We should have about 8 more. I just got an error message that says slow network connection. Anyone else? That's why I was nervous to
No, I didn't see it.
I was nervous to do this from the office.
Cameras, because sometimes that helps.
Yeah, we might want to turn off our cameras.
Okay. Does everybody?
Yeah, because that does help sometimes. I'll try it.
Sure.
Click. We're still here, Noe.
Okay. Does everybody hear me now?
Yeah,
Yes.
that's better.
Okay. So I just want to know who's here.
So right now it's the 4 of us and Michelle Corona. Hi, Michelle. Hi, Michelle. We are actually not using our webcams because we're getting messages that our network connection is slow. So we're trying to maximize our bandwidth here by not using webcams. But go ahead and turn your mic on and we can participate like that. Now we're welcoming in Carlos Ortiz. Hello, Dr. Ortiz.
Hello. How are you?
Hello.
Hi. I was just telling the group that we are having network connection difficulty.
Hello, everyone.
So we are not using, Dr. Ojeda has just entered. So we're not using webcams to kind of free up some of our bandwidth. So please turn off your webcam so that we can maintain a good solid connection here. But we can all participate via the chat as well as with our audio microphones. So joining us just now, we have Dr. Ojeda, Dr. Villegas, Dr. Arellano, and Dr. Criollo.
Okay. Hello, everybody. I think I want to start. We have another meeting at 3 o'clock.
Sure, go ahead.
So, everybody, Dr. Criollo and Carmen, we're turning off the cameras because the internet connection is slow. So you can turn it off.
Yep, and we just welcomed Juvenal to the group as well.
Thank you. Okay, well, thank you everybody for being here. This is going to be a short presentation on statistics or data analysis for program review. Even though I do not have everything that we're supposed to have in a program review, but I'm going to give you some of the things that I consider important in statistics in order to do any kind of analysis. Okay, so I follow the pamphlet that was given to us by Dr. Villegas and Jennifer, and I just want to do a few of those items. Okay, so we want to know how to do some kind of data analysis. I will use Excel to do the data analysis. Okay, so if you have Excel and you want to follow that, that's okay. I have a lot of data though, so you may be able to follow, but I will send you the file. So I will send you the file and then you can follow from there. Okay, so most of the data that I have is, I made it up, so it's not any compromise in the data.
Okay.
Okay, so and so then we can follow the formulas and the graphs, but really when we do the analysis for program review or class assessment, so the statistics is not so difficult. It's just gathering the data that may take some time. Okay, so so you're seeing my screen. Okay, so I want to start by what are we doing? I know that not everybody here has deep knowledge of statistics, so I want to start with the basics, which is statistics for program review, quantitative analysis. So we always start with the population, which is all members of a defined group that we are studying for data-driven decisions. So that is all members. So, and the population could be anything or any items that you want to study or any individuals that you want to study. Okay, so the rule of thumb for this case, so this is not always true for the general statistics, but for the pamphlet that was given, so we want to have a rule of thumb in which we say that we need to study the entire population if there are less than 35 observations. So we know that we are dealing with small data sets, and if we have only 35 observations or less than 35 observations, then we want to study all of them. Okay. So if the population is more than 35 observations, then consider sampling. So we need to be able to take samples. So we want to have the samples that are unbiased. So we have a sample, it's a subset of the population. And if you have any questions, please just let me know, okay? Okay, so what do I mean by unbiased? So every student should have, in this case, I will relate it to students. So every student should have an equal opportunity of being selected. Do not exclude certain individuals based on gender, major, etc. Okay, so even if you feel like the student has a low score, and it should be included. So everybody should be included, unless later on I will at least mention that there are certain cases in which we have outliers. But in order to determine the outliers, we must do a test for outliers. Okay, so we cannot just pull out the information. We cannot just take it out. Okay, does everybody see my screen?
Yes.
Okay. Simple random sample, randomly selecting a subset of participants from the population. each member of the population has an equal chance of being selected. That's one of the ways to select samples. Okay, so we also have systematic sampling, which is arranging in alphabetical order and selecting a starting point at random and then selecting every kth student. Okay, so that's another way of selecting the students. How do I minimize? Sorry, I'm sorry. I just want to be able to see. I just want you to see the paper only. Because you're seeing Juvenal and Dr. Villegas, right?
Yes.
Yeah, we can see that. I can see the paper too. I can see your Word document.
Oh, okay. Okay. So
No,
that is.
do you want to remind that, okay, they're no longer, we no longer see them. I just wanted to see if you wanted to remind us to have our cameras off.
Yes, thank you. Okay, so basically systematic sampling is, I mean, you take a starting point and you say, for example, choose every third student. In that case, K will be equal 3. Okay. So that's just one way of selecting the samples. Okay, so, and then we go on to descriptive statistics. So is there any questions so far? Okay. So descriptive statistics, and this will depend on what are your needs. What do you want to see in the data? So this is, so these are the basics, but there are many other things that you want that you may want to see. Okay. So it just depends on what is that you're looking for. Who do you want to compare? What do you want to compare? There are many things that we can do. Okay. So these are the basics. So we have the mean, which is just the regular average. We have the median, number in the middle. We have the mode, the value that appears most frequently in a data set. We have the variance, it's a measure of how far the values in a data set are from the mean on the average. And we have the standard deviation, a measure of the spread of the values in a distribution. So a low standard deviation means that most of the numbers are close to the mean. Okay, so this one, I believe, I believe that the standard deviation to me is one of the most important items that I want to see, that I always study. Okay, because what I have seen in my last year when I was doing data analysis for the classes, I have seen that the standard deviation is very high. So that means that there's a lot of variability in the results from the students. So the students are taking a test. The standard deviation is high. That means that the students are not learning the same. So some of them are learning very well. So they are learning at 100%, and some others are too low compared to the rest. Okay, so that's a measure that we really want to see. The mean is also a good measure, but the mean can change if there are some low values or outliers. So we have to be careful with the mean. So most of the time we take the mean as the main statistic, but in reality, you have to see which one will be better for your data set. Okay, so many people use the median because that's the number in the middle. I always want to see the standard deviation. Is there any questions so far?
It looks like Dr. Ortiz has a question.
Yes, Dr. Ortiz?
Oh, maybe not. I saw his hand was raised.
Yeah. No, yeah.
Go ahead, Dr. Ortiz.
Oh, sorry. I'm sorry. Yes. No, in case that we decide and to use the sample instead of the total number of students, what is more or less the margin of error if we use a sample? Just is there any margin of error, that we can take into account? For example, if I have a class of 50 students, if I decide to use a sample, what will be more or less the margin of error in that? If I decide to take a sample
Okay.
instead of
Yes. According to the pamphlet that was given, the margin of error should be 5%.
Right.
So in reality, we want to take as many students as possible. So if we have 50 students, I will study the 50 students. But that's just because I want to know everything that there is about the students. Unless the number is very huge, if we're talking about 500 students, 1,000 students, then I may take a sample of 250 students or even 100 students, because in statistics, anytime that you have a sample greater than 30, then it's considered to be we can make the assumption of normality. Then it's still a good sample, but then it just depends on how do you collect the data. If you have outliers, there are other items. But even 50 is considered to be it's a good data set, but I will not take a sample. If I have 50, I will do the 50.
Thank you, Noe. Thank you. Good.
Okay, so let me show you why we have a data set of or 35 or I said 30, but in the pamphlet we say 35, but those are similar numbers. Let me show you in Excel how to calculate it. So we have the mean equals average, the median equal median, mode equal mode. Even though here in the mode, you can have multiple modes and Excel will not give you the multiple modes. So population variance, variance.p, sample variance, variance bar.s, standard deviation of population, standard deviation of sample. Okay, so like I said, I will send you this document. Let me go on this. So this is just an example of test score. Okay, so I have my test score. As you can see here, this is a very small data set. I only have 10 observations in the count. So I can calculate the mean. Like I have it here, I will send you that cell also. If you click here, I have the formula equal average, and double click. Then we can take the average. And do it as an array. So just highlight it. You can take the median. In this case, this is a sample, so I'll do sample variance. So var.s. and sample standard deviation. Okay, but just thinking logically as far as you know the class and you know that the grades of the students go by 10 by a difference of 10, right? So an A is 90%, B is 80%, and so on, right? So look at the standard deviation. The standard deviation is 12. So that means that there is a difference of 12 among all the students in the standard deviation of 12. Okay, so I guess if you compare that to other groups, then it could be high or maybe it's not. So depending on what are the other scores from other groups. Okay, but here I have a sample of only 10. So here I'm going to say n equals 10. And I have here another sample. This is a much bigger sample, 36 observations, just to do more than 35. So n equals 36. And I did the same calculations. Did the mean, the median, sample variance, standard deviation. Now the standard deviation here is 9.63 compared to the standard deviation of 12 when you have less students or a smaller data set. Okay, so in terms of being reliable, you want to have more than 35. In order to be reliable, you want to have more information. You want the observations tend to get less bias if you have more. Okay, and so the standard deviation will be a better value than if you have a small data set with more variability. So there's more variance in the smaller sample. Okay, is there any questions so far? No? Okay, so before I proceed, I usually do two tests. One of the tests is the distributions. I usually do a distribution, and I did it here for this distribution, and this is a histogram. Okay, to see how the scores are distributed. Okay, let me show you how I did this histogram. So I highlighted the scores. Just going to insert, recommended charts. And then in all charts, you should see a histogram. Okay, then you should see the distribution. So we always talk about not being a normal distribution. Those look like a symmetric bell-shaped curve. That's what I always want to see, whether it looks like a symmetric bell shape or not. Okay, so this is one of the items that I do to see if really the analysis makes sense. Another one is outliers, and I do have it here. which are stream values. And for that, I'm going to do what is called a box and whisker plot. That's one of the ways to find outliers. Okay, so far I had done a histogram. And now I'm going to do a box and whisker plot to see if any numbers are stream values. So I highlighted my data, went to insert, recommended charts. In all charts, you should see a box and whisker plots. Okay, so I have my box and whiskers plot, and if there are outliers, there will be a point outside the tails. Okay, so here I do not see any outliers. So that means that my data set, I do not have to worry about stream values. Okay, but let me see what will be a stream value here. If I just change my value here, so for example, at 30, and you see that point at the end on the lower side. So I have this point, and that's an outlier. Okay. Now it all depends on if I had more numbers closer to 30, then maybe it will not be an outlier anymore. Okay. But I can see that my numbers here are high, from about 55 and all the way to 95. So if any number are inside here, then that means that the data is normal. It follows a normal distribution. But if only a few or only one is below, then it will become an outlier, or it could be above. So maybe somebody obtaining 100, and maybe that's an outlier. But I cannot say that if it is an outlier until I do the box and whisker plot, and then I see I can validate my data by showing that in reality it is an outlier. Is there any questions on this?
Yes, Noe.
Yes.
Just, okay, so when you have an outlier, whether it's on top or at the bottom, do you recommend to remove it and not include it in the sampling? And so that you can report more accurate assessment?
Well, that will depend on why do you, it will depend on the reasoning for doing the analysis. And also will depend on why do we have an outlier. This is certainly something that you may want to see. If there is an outlier, you want to see the reasoning of why do we have an outlier? Why do we have outliers? So there could be something like the student not attending class. There could be some other reasons. Now, in education, we usually include it, okay? And then we want to find the reasoning. In industry, they may decide not to include it. So it just depends on the study. There's always an explanation and recommendations that you can do on any study. And so you do have outliers, you want to see why do we have those outliers.
Okay, thank you.
Thank you, Ronald. That was a really good question. I think that Dr. Ortiz, we discussed this before last year when we were deciding on what to use for math. And I think that you want to include all of them, right? Is that correct? That was, you wanted to include every single item. Okay, but anyway, then it depends on the study. But you definitely want to notice that you do whether you have an outlier or not.
And if you remove it, it should be an explanation in your report, correct?
Correct. Yes. Okay. So again, and I do use it just to be conforming to see what is that I have. Especially if I'm giving a test on the final exam and I see an outlier, well, then I know that in reality it's an outlier and it's not part of the, and it doesn't mean that, the teacher is bad, right? So if it is an outlier, right? Sometimes one person does bad because they didn't study at all, or they didn't go to class. So, but it shouldn't be reflective on the professor.
And
Okay.
and just to add a little bit more to it, we have obviously we have special students, and that's another one that, well, I just to mention it, that could be something that could be reflected in this area that we're talking about.
Yes,
Yeah, in sciences, Noe, sciences, and math, we have a lot of outliers in respiratory, and in math we will have a lot in statistics, and
yes, well, like I said, we just want to notice that they exist, and when we want to prove it, we want to validate the data. And in this report, we want to, they're talking about validity and reliability, and these are ways to show that we want to make the data valid. Okay, so like I said, I will send you this. Now, let me show you institutional outcomes. I did quantitative fluency. Okay, so the first thing that we want to do when we do institutional outcome or the objectives, class objectives or program objectives, all of those can be in the same way. Okay, so I did quantitative fluency. We had to map the questions either to the midterm or the final exam. So we need to know what questions we want to use for that purpose. Okay, and we need to record the scores from the students. So this is for data collection, and then analyze the results. Okay, so I did a sample of what I did for statistics before. Let me show you what I have here. So I did it for the midterm. So this is for quantitative fluency. As you can see here, I have different sections of Math 225. So I have the midterm. I did, these are the questions that once we map the quantitative fluency, we have that those questions are an indicator of quantitative fluency. So they map to quantitative fluency. Question number 6, number 8, number 9, number 10, number 11. Okay, then from those we need to record the score from all the students. In this case, we did it for Math 225, so I just have this example, Math 225. So I have every student who took Math 225 in that semester or that term for those questions. Okay, so I have 30 students. Okay, so once we have the results, then I just took the average. So the average. So I did the average for every question. I did when I did the average, I always do dragging. So you drag it to calculate with the same formula. So I did the dragging for the rest just to make it faster. And I have here as the score, but when I do the graphs, I want them to show as a percentage or as a decimal. So here I went back and divided it by 100 to get the decimals. Okay, so this last one is the overall. Okay, so I have the following. So I have every question, number 6, number 8, number 9, number 10, number 11. I can copy it. I always find it easier to do it vertically instead of horizontally. Okay, so in itself, we have to be very careful in copying because we're using formulas. So I always copy with the 1, 2, 3 to copy only the value and not the formula. So I know this is double work, but in itself is very sensitive. So we have to use it that way. We can change the percentages, the percentage formula. Okay. And usually a bar graph will be a good representation of these items. So it's going to highlight and do a bar graph. You see in the recommended charts, I always go to recommended charts just to see what will be a good option. And so this is my bar graph. And I can change my bar graph to show the axis. Okay, to show the data labels. This is the one that I like to see exactly the percentages. I'm just changing the titles. Okay, and this is what I will present. Okay. Of course, one of the items that we always want to discuss within the department is what will be a good benchmark for the results. Okay, as you can see here, I have the overall 72% in quantitative fluency. Okay, so to me that's not high. That's actually could be low, right? So, but that's something that we need to decide to see what will be a good benchmark for the overall. Okay, and then we have other things. So, for example, we have number 9 at 60%, number 10 at 60%. So those are low, and you might want to address those questions and to maybe ask the professors to teach to spend more time on those topics. So maybe in the future will be higher. Okay, is there any questions so far in this? Okay, so I did the midterm. This is for one of the terms or one semester or one of the terms. And then I also did a midterm for the second term. And it will be the same process. Okay, so I'll show that. So we have again the data. We want to calculate the average. Again, I changed it to decimals to have it in percentages. And it just get repeating. And this is the overall. So yeah, when I copy it. And this is the one that you need to be careful with when I copy, because this is the one that has a formula. So I want to copy it with the 1, 2, 3, so that it will copy only the values. And then I can change it to be vertically. Okay. Then I can go on to do my bar graph. You can see here, I did not change it to percentages, so that's why you're giving me the decimals. And we can see here in the final exam, well, this is the midterm for another term, how the scores are better compared to the midterm from the first term. You see number 9 and number 10. Number 9 and number 10, when both of them went up. Okay. Do you have any questions so far?
Noe?
Yes.
So basically, more or less, correct me if I'm wrong, this is more or less the same analysis that quiz statistics does in Canvas, right? Because more or less it does like item analysis as well as the standard deviation, the average. I use that feature in Canvas, which more or less give me more or less the same results. So I don't know, have you used it in quiz statistics in Canvas?
Well, the only problem that we have, that I have in Canvas is that it doesn't show me exactly what I want to see. It does show the mean standard deviation. It has many of these features, but as long as you can relate it to what you want to see, then that's okay. That's what you want to. That's what you want to see. For example, for this one is specifically to quantitative fluency, and that's what we're trying to figure out the way to collect this data from Canvas. So what I'm doing now to map it to quantitative fluency or to map it to the objectives of the class and to get only that information. Because you know the rest is general information, so that's you know that you can get.
That quantitative fluency is not the same as the item analysis, or is something different? Just correct me. Because that
No,
Canvas gives you item
this is
analysis.
from the institutional outcomes. Yes, it does give you item analysis, but it will give it to you by even by question. In this case, I'm going by question, and Canvas can do that. But to collect it together, see, and then to do the graph only from those questions. So that's something that you want to collect from Canvas.
Yeah, so this example is for quantifying the institutional learning goals, and one of those is quantitative fluency. So we're just picking out those items that we've determined help measure this institutional goal of quantitative fluency. So it's only calculating these values for a very small set.
Yes, correct.
Yeah, so Canvas wouldn't be able to do that for you.
Yeah, but we're trying to get there so that we can collect it directly from Canvas, if we can map it. I talked to Rafael Torres, and we want to see what will be a way to do that, so that we can get that information in use the way Dr. Ortiz described the rest of the information. So we can map it to be only for specific outcomes, for specific institutional outcomes, or for specific program outcomes. But right now it's not there. We don't have that yet. Okay, is there any other question on this? No? Okay, so we're almost running out of time. I do want to show you something something else because the other graph was going to be similar as far as the calculations, but I can send you the end result. Okay, because the other graph is just going to be in aggregate, so putting it together and doing it one more time. So we can follow. You can follow. I think what you have seen. I want to show you something else, which is described in the pamphlet, which is the t-test. Why do we need to do a t-test? And I think that's very important because the t-test will tell us if there is a difference in the means or difference in the classes, or whether they are coming from the same population or not. Okay, so some classes may be too different. Okay, and so if we can prove that those classes are different, then we should think about whether to review those classes. Okay, so that's what I want to show you next on this, and we're running out of time. I knew what the 1 hour was not enough, so we'll plan on doing and continuing with this. Okay. So we have the following. We have two sample t-test is used to determine if two population means are equal. So, which in other words, we want to determine if there is a significant difference between those samples, so that we can say that they are not coming from the same population, that they are different, or whether or maybe not, or maybe they are. Even if they look different, they may not be different. Okay, so we do that by doing the following. We have a two sample t-test for unpaired data, and we have this is the null hypothesis. Okay, the null hypothesis HO. Okay, so we have the null hypothesis and the alternative hypothesis. Okay, so we're saying we want to prove the following. We're testing if the two means, whether the two means are equal. So the null hypothesis, we're saying they are equal. So the mean of the first sample is equal to the mean of the second sample. The alternative hypothesis is that it's not. Okay, so I did an analysis in Excel. For the following. Okay, so I have two sections. I have final score, two sections, section 1 and section 2. And I just did different numbers, and numbers could be, once we have real data, then we will be able to do this for real data. Okay, so what I do is this is for this you have to download a specific data analysis tool pack from Excel, which I already downloaded. But if you want to download it, send me an email and I'll show you how to download it if you haven't. Okay, so I can show you real fast. Okay, I can show you. So it is in options. Okay, so you have to go to add-ins and add-ins and do the analysis tool pack. Okay, I didn't hit go, but I already have it, so that's why it's not doing that for me. Okay, so I did go analysis toolpack and analysis toolpack BBA. That will give you an analysis toolpack for your Excel. Okay, and then once you have that, then it becomes easier because you have a data analysis menu. And here I have the t-test. So I have different ones. The one that I use is t-test two sample assuming equal variances. Okay, because the variance cannot be so different if they are you are doing the same test, for example. Then it's going to open up. Okay, you have the different variables. You have the variable 1. You have to highlight the array. And then the 2. Okay. So you have the alpha 0.05, that is the significance level. Okay, the output range. And I can just pick any cell. So I have it here down below. And you get the results here. Okay, so I have the result here. And I just look at one item only, which is the p-value. Okay, so the p-value. Now, if I have here, I wrote it here in the conclusion. So if the p-value is less than alpha, reject the null hypothesis. Okay, so that's the easiest way to do it. Okay, so here my p-value is 0.03. The alpha that should be used for these problems is alpha 0.05. So that's 5%. Okay, so you can say here that p-value is less than alpha. Therefore, reject the null hypothesis. Okay, the means are not the same. Which means that there are two different populations. Okay, and let me tell you why we do this. So basically, if we're having two different sections of the same class, you definitely want the scores to be similar, right? So if they are not, if you have one section that is having very low scores, then you can prove that the teaching or the class is not the same. It's not, they are not, maybe the professors are not teaching the same materials. And this is a way to validate that they should do a review for those classes or maybe change the professor. Okay, is there any questions for this information?
So for this sample, Noe, you mean to say that these populations are not similar and that it would be worth looking into to understand why the results between these two class sections are different?
Correct, yes.
Okay.
Okay. Is there any last question? Okay. Well, and if we need to have a second meeting, then we should schedule it for later on. Okay. So I think that there are many things that we need to study.
Sure. I'll work with Noe to create a second session where we can go into these topics a little bit more in detail, and we'll send out registration information for that sometime in April.
Yeah, my recommendation would be to actually take, I mean, I guess like a workshop. It would be nice. Thinking about workshop where you can actually, I don't know, implement some information that we need to do for assessment. So it's beneficial for everybody.
Noe, I have a question.
Yes.
Yeah, can you send us I don't know, a pamphlet or a summary of these, or any copies for us to refresh this?
I will send you the cell worksheets and the Word document.
Okay.
Okay. Well, thank you everybody for attending this meeting. And I think it's already 2:59, so we need to
We got another meeting.
Yeah.
Yes.
All right.
Thank
Thank
you.
you. Thank you, Noe. It was really good
Thank
to
you,
see
Noe.
how.
It was good.
Yeah. Great.
Do another. Bye.
Bye.
What is
Bye-bye.
a 3 Noe?
Bye-bye, everybody. Thank you.